Good morning, everyone. Today, my name is Yam Pui Mun, and today I will be presenting the topic of effects of PBA on achievement and attitudes among low proficiency chemistry students in private schools. Table of content include first, introduction, second, literature review, third, methodology, fourth, results and discussion, fifth, conclusion, implication, and recommendation. Introduction. Chemistry study involves the properties, composition, structure, and energy changes of elements and compounds. Relevance issue is that students often find chemistry irrelevant due to the lack of practical application in traditional assessment. Conventional assessment is that focus on rote memorization rather than practical understanding, leading to disengagement. School-based assessment in Malaysia, implemented since 2012, emphasize performance on specific learning objectives. PBA focus on application and practical context, aligning with curriculum goals. Benefits of PBA instead is enhanced engagement and achievement in chemistry, especially for low proficiency students. Private school chemistry curriculum is designed to build a strong foundation in chemical principles and practical skills, preparing students for the Unified Examination Certificate. Challenges with conventional assessment is that low proficiency students in private school face high dropout rates and low test scores. Impact of positive attitudes. Positive attitudes towards PBA can improve student engagement and achievement in chemistry. Importance of assessment practice. The tailoring assessment method is crucial for improving low proficiency students' attitude and achievement in chemistry. Research question. First, what is the effect of PBA towards the low proficiency students' achievement in chemistry? Second, what are the low proficiency students' attitudes towards PBA in chemistry? Literature review. Assessment as a bridge between teaching and learning. Assessment's role. AFL, formative assessment guides the real-time learning, support continuous improvement. Summative assessment evaluates the learning at the end of a period. Current practice in Malaysia. Private school emphasize summative assessment. AFL is underutilized. PBA is a form of AFL effective in improving low proficiency students' chemistry performance. It focuses on practical application and real-world problem solving. It enhances skill development, aligns with real-world standards. Conclusion is that shifting to formative assessment like PBA can improve student outcomes and engagement in chemistry. Types of PBA. Product-oriented assessment evaluates the final outcome of product like report and video. It focuses on accuracy, completeness, and quality of the results. Second, performance-oriented assessment assesses practical skill application under teacher supervision. It includes activities like oral reports, demonstration, and lab work. Process-oriented assessment examines students' thinking, reasoning, and methodology. It focuses on scientific process, including hypothesis formulation and data interpretation. Challenges in implementing PBA. Increased complexity requires assessing multiple aspects of students' ability within limited time. Time consumption. Extensive time is needed for preparation, performance, and evaluation. Professional planning. Lack of leading to inefficient assessment and stress for teachers. Subjective judgment. Concern about fairness and consistency in grading compared to conventional tests. Student attitude. Increased pressure and anxiety, especially with public speaking or demonstration. Feedback and content mastery is less structured and it focuses on skill over content mastery. Adaptation issues. Students struggle with practical demonstration of knowledge required by PBA. Difference between PBA and conventional assessment. In terms of nature of assessment, evaluation method, time and preparation, and evaluation style. In PBA, understanding of theories and content mastery through test, quiz, and standardized exam. Evaluation method include tasks such as projects, presentation, portfolio, experiments, simulation are involved for students to demonstrate their learning in action. In conventional assessment, assessment is organized with objective time and preparation. Time consuming due to the preparation, planning, and execution of tasks. Conventional assessment less time-consuming as students prepare by studying specific material or content outlined in the curriculum. Evaluation style, subjective judgment because of no clear-cut right or wrong answer in PBA. Conventional assessment, perception of objectivity in grading due to the use of predetermined answers or clear-cut criteria for assessment. Benefits of PBA in chemistry. Real-world application. It provides hands-on experience that simulates real-world scenario. For example, analyzing environmental samples, synthesizing industrial compound, exploring reaction. Enhanced critical thinking. It encourages deeper comprehension of interconnected chemical concepts. It designs, experiment, troubleshooting, and interpreting results. Develop practical skills. It involves handling equipment, measuring, and analyzing substance in lab setting. Reinforce theoretical concept through direct engagement with chemical phenomena. It builds confidence and essential lab skill for future research or professional endeavors. It reduces emphasis on memorization, shifting focus from rote memorization to understanding and application. Tasks involve designing experiments, interpreting data, and drawing conclusions. It aligns with modern educational principles, emphasizing deeper learning and analytical skills. Low proficiency students in chemistry subject. Definition: it is failure to attain fundamental skill in chemistry. Contributing factors include limited prior exposure to scientific concepts, ineffective teaching method, language barrier. Challenges face difficulty applying concept to real-world scenario. Students have low confidence, leading to disengagement and reluctance to participate. Effective strategies include personalized instruction and targeted limitation, hands-on activities, and ample practice opportunity, active learning, and small group activities. Cognitive constructivism learning theory in chemistry education. Active knowledge construction. Students build knowledge by integrating prior experience with new information. PBA promotes active engagement and application of knowledge in real-world chemistry problems. Incorporation of prior knowledge. Learners build new knowledge on existing foundation. Thus connect familiar concept with new scenario, enhancing understanding. Scaffolding support. Provide structured guidance such as the rubrics and peer feedback to help students tackle complex chemistry tasks. Scaffolding enables systematic problem solving and support higher cognitive abilities. Real-world context. PBA tasks simulate real-world chemistry problems, enhance balance and understanding. Application of theoretical knowledge to real-life situations. Learning. Development of metacognitive skill. It encourages reflection, self-assessment, and planning strategies. It promotes monitoring and refinement of learning approach, improving comprehension of chemistry concepts. Attitude of low proficiency students towards PBA in chemistry. Challenges with conventional assessment. Low proficiency students struggle with assessment, focus on rote memorization rather than practical application. PBA shift focus towards real-world skills and knowledge application, potentially aligning better with these students' learning needs. Initial attitudes towards PBA. Past negative experience with assessment and feelings of inadequacy can lead to apprehension or resistance towards PBA. Unfamiliarity with PBA and uncertainty about evaluation method may affect attitudes negatively. Importance of a supportive learning environment. Clear guidelines, practice opportunities, and feedback are essential to alleviate anxiety and build confidence. Scaffolded support through rubrics, peer feedback, and teacher guidance help students approach PBA tasks effectively. Methodology. Research design. Research methodology. We use quantitative research involving the collection of numerical data and the use of statistical methods to analyze the relationship between assessment methods and students' achievement in chemistry. Research approach. Quasi-experimental design with a control and treatment group in a pre-post test setup, exploring the effects of PBA on low proficiency students' achievement and attitudes. Participant selection. We divide the participant into control group and treatment group. Both groups undergo pre-test phase, and then control group undergo traditional method with the PBA. Treatment group undergo the intervention phase with PBA. Both groups after that carry out post-test phase, data collection, data analysis, interpretation, and conclusion. Approval process. Formal request was made to private schools in JB. Approval took 2 weeks. Teachers and students provided consent to participate. Pilot study. Conducted in one school to test methodology and research instrument. Feedback informed adjustment to the study design. Sample selection. Low proficiency chemistry students were selected from the two private schools. Control and treatment group formed through purposive sampling. P-test, a lesson on water electrolysis was given followed by a pre-test to establish baseline proficiency. P-tests include multiple choice answer and problem-solving questions. Intervention phase. Treatment group received PBA, including presentation, lab work, and report writing over 4 weeks. Control group continued with traditional textbook exercise. Presentation. Students in the treatment group present on water electrolysis concept, assessing their understanding and ability to prioritize key information. Lab work. Students perform water electrolysis experiments, following safety protocols and documenting their findings within a 1-hour session. Report writing. Treatment group students wrote a comprehensive report on their experiment, including methodology, data analysis, and conclusions, post-test and attitude questionnaire. Both groups completed a post-test and an attitude questionnaire about PBA immediately after the intervention. Data analysis. Pre-test and post-test scores were analyzed using SPSS to measure changes in academic achievement. Spearman correlation test was used to analyze students' attitudes towards PBA. Data analysis. And this is the summary of the data analysis. The instrument include pre-test and post-test and also questionnaire. Analysis include independent sample t-test, median and mode, Spearman correlation test. Results and discussion. First, effects of PBA towards low proficiency students' achievement in chemistry. Descriptive of pre-test result. Control group have a mean of 7.43, minimum score of 2, maximum score of 14.5. Treatment group with a mean of 8.56, minimum score of 3, maximum score of 14.5. Differential statistic of pre-test results shows that there is no significant difference between the pre-test, experimental, and control group. Descriptive of post-test results. Control group have a mean of 9.68, minimum score of 2, maximum score of 18. Treatment group have a mean of 24.81, minimum score of 13.5, maximum score of 34.5. Inferential statistic of post-test results shows that there is a statistically significant difference between the post-test mean score of the experiment group and the control group. PBA provide ample opportunity for teachers to have guided discussion in the treatment group classroom. This discussion fosters numerous ideas, consequently enriching students' comprehension of the pertinent problems. The utilization of PBA helps to engage students towards their lesson. It facilitates the systematic problem-solving process, consequently resulting in an augmentation in students' interest in chemistry learning. This outcome validates the finding of Udemy in their investigation of the impacts of PBA within classroom setting. Their research revealed that students who execute PBA in class exhibit more robust problem-solving abilities compared to control group. Descriptive statistics between pre-test and post-test of control group. They have a mean of 2.25. Minimum difference between pre-test and post-test of control group is negative 3.5. Maximum difference between pre-test and post-test score of control group is 7. Treatment group have a mean of 16.25. Minimum difference between pre-test and post-test score of treatment group is 7. Maximum difference between the pre-test and post-test score of treatment group is 23.5. Students' attitudes towards PBA. Students' attitudes towards opportunity provided by PBA. The data indicates a clear preference among students for interactive and practical assessment methods such as presentation and lab work over traditional methods like tests and written reports. This finding emphasizes the importance of incorporating valid and engaging assessment strategies in chemistry education to better cater to students' ability and preference. Students' attitude on how they should be graded in PBA. The results indicate a clear preference among students for traditional and practical assessment methods such as tests and lab work over presentation and report. This insight suggests that students feel more confident and secure with this established form of assessment. Effects of PBA on students' attitude towards learning. While tests and lab learning are widely endorsed by students as beneficial for learning chemistry, presentation and reports show more mixed perception. Students' attitudes towards fairness of PBA. While tests, presentation, and lab work are generally perceived as fair form of assessment by students, reports present challenges in maintaining perceived fairness due to potential subjective bias in evaluation. These findings underscore the importance of transparency, consistency, and clear criteria in PBA to enhance perception of fairness among students. Students' attitudes towards getting a good mark in PBA. The data underscores varying level of understanding across different types of assessment, with tests and lab work generally perceived as clear in terms of assessment criteria compared to presentation and report. Students' attitude regarding time consumption of PBA. Varying perception among students regarding the time consumption associated with different types of assessment in chemistry education. Tests and presentation are generally seen as more time-consuming, whereas opinions on lab work are more balanced. Reports stand out as particularly time-intensive, reflecting the extensive effort required to complete them effectively. Students' attitude regarding how PBA reflect their activity in chemistry. Findings highlight that while tests and lab work are widely accepted as effective measures of proficiency in chemistry, presentation receive mixed perception and report are viewed less favorably. Students show robust support for using tests and lab work as grading component in chemistry education, reflecting confidence in their effectiveness and fairness. Presentations and report, while generally accepted, receive more mixed perception, indicating potential areas for educators to consider when implementing PBA to ensure alignment with student preference and equitable assessment practice. Students' attitude on how PBA motivates them to put more effort into their classwork. While tests and presentation are widely perceived as effective motivators for students to invest more effort in learning chemistry, lab work also play a positive motivational role despite some mixed perception. Reports, however, are viewed less favorably in terms of motivating students, potentially indicating a need for educators to explore alternative methods to enhance engagement and motivation in this area of assessment. Experiment correlation test between test, presentation, lab work, and report. A strong positive correlation was found between performance in test and presentation. A significant positive correlation was observed between test score and lab work. The correlation between test and report was weak and not statistically significant. There was a statistically significant positive correlation between presentation skill and lab work performance. Conversely, the correlation between presentation and report was very weak and non-significant. A significant positive correlation was found between lab work and report score. Conclusion, implication, and recommendation. Conclusion, a significant improvement in chemistry achievement for students who engage in PBA compared to those who did not. And in Spearman correlation test, strong positive correlation was found between test and presentation, test and lab work. Weak or non-significant correlation between test and report, presentation and report. Statistically significant positive correlation between presentation and lab work and report. Implication. Educators should adapt and extend PBA to all students to enhance conceptual understanding, improve care achievement, and tailor assessment strategies based on students' attitude. Researchers should replicate the study, explore different assessment strategies, and focus on measuring attitudes towards PBA to define and expand its application. Private schools should integrate PBA into their curriculum, invest in teacher training, and involve parents to improve student achievement and lead in educational innovation. PBA offers a supportive, engaging, and effective approach to improve law proficiency, students' performance, confidence, and long-term interest in chemistry. Recommendation. Educators should incorporate PBA into chemistry lessons with activities tailored to students' needs while implementing continuous monitoring and evaluation to refine assessment practice. Additional support such as tutoring and extra resources should be provided to help low proficiency students excel in PBA tasks. Future research should expand data collection method and participant diversity to gain deeper insight into PBA's effectiveness across various contexts. Studies should explore the important impact of contextual factors like school culture and policy on PBA implementation and outcome. Thank you.